Good, so welcome back. Hopefully you've watched the first video on how to set up Topaz Editor to work with Topaz and how to do a simple rebuilt refinement. What I want to do in this video is show you some of the power editing tricks that are available in Topaz Editor, what makes it so much more powerful than JEdit. So what I thought I would do is I've got a dummy input file open, and I'll go through this input file and basically tell you some of the clever things you can do in the various different menus on the left-hand side. So let's start with the top menus. We talked already about the help menus, sending files to Topaz. One thing we didn't mention was this archive input file command. We said that every time you run a Topaz refinement now through JEdit, it makes a little backup file. What archive does is it makes a permanent backup. So the backup file, if you just run regularly, only survives one refinement. What archive will do is it makes a little time-stamped file in your directory. So if I open my directory, there's a file that's just been created called Topaz Editor Tips with the date and the time at which that file was saved. So that is an archive for all time if you need to go back to things. So hopefully that will be useful. In the help menu, we looked at some of the help features before. We looked at the new manual and how it lets you work with Topaz keywords. So if you've got Topaz keywords in your input file, as we said before, you can hover on the str command and you get some simple commands, and you also get a link directly to the technical reference. The things like macros, so the zero error command is actually a Topaz macro. If you hover on that, you get a different option. You get to view it in the macro browser. So if you click on view in macro browser, again, it opens up a little HTML file on your computer at the point where the zero error macro is defined. So you can see how that particular macro works, and you can browse through all of the other macros which are related. So that's hopefully useful. If you click on the zero error one itself, you get the option here, open in editor. So if you click on that, what it should do is it should open that the Topaz macros directly in Topaz Editor, and it opens them at the right page for the 0-point refinement. So you can see exactly the syntax that goes into that macro if you're interested. Okay. The other thing you can do with hover help is there is a little option here which is hover help read all. If you click on that, you basically get all of the help in one place, so you can read through and see the most common help things that people tend to need in Topaz. We looked at the manual before. We looked at the space group browser before. Remember, there's a web page which has got all of the space groups that you can use by default in Topaz. The actual number that you can type in is slightly larger than this, but these are the ones that are intrinsic to Topaz and defined in its sgcom5 file. So you can filter those by triclinic, monoclinic, orthorhombic, whatever you like. Web links for help. So there are web links here to all of the common things. So the Topaz wiki, the Topaz forum, this YouTube channel, space group tables, etc. So hopefully everything that you need should be in the help menu. One thing that's new in the help menu is this search imps for text command. What I find a lot when I'm working with Topaz is I can remember that at some point in the past I did a stacking fault refinement, but I can't remember the exact syntax of the input file. What you can do is you can type in any word that you're interested in. I'll type in the word stack. I'll hit return twice. And what it does is it goes away and it looks through the Topaz example files for every input file it can find that contains the word stack. So for example, if I open cowlenite.imp, that's an input file that's somewhere in it. Yeah, it's a stacking fault refinement. So if I wanted to remember the syntax, I can just look at that refinement. So by default, when you click search imps for text, it just searches the Topaz examples. If you want to look on your own hard drive as well, if I want to look at for all the examples that I've worked on with neutron data on this particular computer, I hit return, and the first window that pops up is actually a directory browser. By default, it just looks in the main Topaz directory. But if I wanted to, I could look through my local data directory and search there for all of my neutron PDF. My files working on neutron data. So, you know, I can open any example that I'm interested in. Who knows what this what this particular one is, but this is obviously a neutron diffraction data file. So because that search is looking through your whole computer, it will take a long time to complete, but it puts up the initial hits straight away, so you can do them. What I normally do is just cancel that command. It will run forever. Okay, so those are the help menu items. Let me just shut down help. The Topaz Durham menus, I think we've looked at already in the previous tutorial. They're basically a series of menus that let you do all the most common things that you'd like to do. We talked previously about the use of templates. You can select a template for any type of refinement that you're interested in. So charge flipping, time of flight, indexing, PDF work, etc., etc. There's a separate menu down here, which is simulate a pattern. Again, that's useful if you just want to simulate a pattern from an existing SIF. This menu lets you do it just by clicking on this button here. And then the final thing that's perhaps useful in the Topaz Durham menus is this bottom menu, which is Topaz examples. Again, if I expand that menu, what it does is it's got links to the Topaz test examples. So for example, if I want to look at a magnetic refinement, if I click on mag here, I'll get a little selection dialog pop up, which lets me look at any of the magnetic input files that come with Topaz. So mag.imp, for example, is clearly a file for doing a magnetic Rietveld refinement. So again, that can be a quick way of finding examples to build your own refinement models on. Good. So that's the Topaz Durham menus. Miscellaneous useful commands. As you can imagine, miscellaneous useful commands in the Durham menus, that's basically a selection of things I do quite a lot but don't quite fit in any of the other menus. So we'll look at some of these in later sections. There's just a couple I want to highlight with you here. One is this insert Z matrix from Gaussian GZMat. So if you work with molecular systems, you'll know that one convenient way of describing a molecular system is to use a Z matrix description. So if you've got a molecule like this molecule glycine, rather than describe its coordinates in XYZ space, you set up what's called a Z matrix to control the refinement. Now, I tended in the past not to use Z matrices very often, not because I don't think they're the right thing to do, but because setting them up was always a little bit difficult. I could never quite remember the syntax for setting up a Z matrix. But it turns out there's a tutorial online, this tutorial on setting up Z matrices, which tells you very easily how to go from a simple sketch of a molecule, and it can even be a two-dimensional sketch, to produce what's called a GZMat file. And so GZMat file is, there's a piece of software called Gaussian, which is widely used in the chemical community for describing species and for doing calculations, and it's got its own Z matrix format, which is this format that's on the screen now. Now that's not the standard Topaz Z matrix format, but it contains all the information that Topaz needs to set up a Z matrix. So what you can now do in Topaz Editor is you can just click insert a Z matrix from a Gaussian Z matrix file, select that Z matrix, and what happens is the rigid body is set up for you in Z matrix format, and you get written into your file the sight lines that you need to work with that Z matrix. So hopefully that will speed up Z matrix work for people. Good. Some of the most important advances in Topaz Editor over JEdit are the ways that Topaz Editor will edit your atomic sites, and particularly handle symmetry in a more sophisticated way than JEdit. We've already seen that a little bit in the TiO2 example that we went through previously. So just for example, is you've seen this before, but here's a structural model for zirconium tungstate, which is a cubic material, and it's just been read in with the traditional Topaz reader. And so what we can do with something like that now is if we right click in Topaz Editor, and let me just minimize the menus. If we right click in Topaz Editor and select symmetrize and refine all, what that will do is it will apply all of the symmetry constraints to the model that are required by symmetry, of course. And you can see, for example, that the cubic unit cell has been set up so that you just refine the A cell parameter, B and C are equated to it. Atoms on a threefold have been equated in the appropriate way. So that's all of the parameters set up for refinement. What I tend to do when I'm starting a rebuilt refinement is I don't want the atoms moving too far from their ideal positions. So what I will typically do is I will try and set my refinement up with constraints to stop the atoms moving too far. And again, you can do that automatically. If I right click on the selection of atoms and I select add min max to atomic coordinates, what that does is it rewrites the atomic coordinates. So what I have now is the atomic coordinates are actually defined by a macro. And in that macro, I store the name of the parameter, the refined parameter, the value in the current refinement, and a reference value. And what you can do with this macro is you can set up a maximum shift on the atoms so that the atoms don't move by more than, say, 0.6 angstroms in any direction from their starting coordinates, or you could set that to a smaller value like 0.1 angstroms if you like. And the other thing you might notice is at the same time I've set up the temperature factors in this particular example so that all of the tungstens have got equated temperature factors, all of the oxygens have got equated temperature factors, and again that's the kind of thing that you would normally want to do early in a refinement. So handling symmetry and refining atomic coordinates is hopefully a lot easier than it used to be. We looked at the zinc oxide example in the last tutorial. One thing I forgot to mention then is if we read the zinc oxide structure in directly using the menus in the rebuilt section, if I read in the CIF file of zinc oxide directly, so that's in the other folder, isn't it? It's in here. That particular CIF file, sorry, I should have read it in. Let me undo that. I should have read it in with the symmetrized command. Let me just read it in again. That particular CIF file is a single crystal CIF file. And if I read it in with the symmetry constraints applied automatically, you can see that those are applied. And actually, this particular example is a single crystal refinement, so it contains anisotropic temperature factors, and hopefully the anisotropic temperature factors have also been read in by topas-editor, and again they've got the right symmetry constraints applied to them. So hopefully again that's something that will speed up some of your work. Okay, so that's all I wanted to say about editing atoms. Yeah, shell script commands. If you're like me and you're slightly older, you probably grew up working on computers, working from command line interfaces. So on a Windows computer, you might have used a command line prompt. On a Linux computer, it might have been a bash shell. What I used to use a lot in the old days is a whole load of terminal commands, things like sort and grep and sed. And what those would do is that they would automatically operate on a file and make changes to it without me having to open the file, edit and save. And it turns out a lot of those commands you can do directly now inside topas-editor. And so, for example, if I take these lines here, so let's say just for the sake of example, I want to sort these lines alphabetically so it's easier to read. What I can do is, I know in the back of my mind that there's a Linux command sort. If I do a right-click topas-editor commands and click on this run command, what I can do is type in the correct command to sort those files. So the file names are in the second column. So I do a sort -K2, enter, and hopefully that will go away. It will read the file and then it will rewrite the atoms in the correct alphabetical order, which has clearly failed because I did the command incorrectly. Let me just try that again. Sort -K2. Okay, so now you can see that the atoms have sorted barium, gallium, and all of the oxygens at the bottom. So that's something you could do. Or it might be that you want to do a more complicated sort. Let's just say, for the sake of argument, you've got a whole series of atoms in the file, and you want to look at the ones with the lowest and the highest temperature factors. So you could do, for example, the temperature factors are in the 13th column of the file. So I could do sort -column 13, and I want to sort them in reverse order. So if I hit return on that, hopefully it'll go away, it'll look at the files, and it should sort them according to temperature factor. So now I've got the biggest temperature factor at the top and the smallest temperature factor at the bottom. Okay, the other command I find useful is grep, and grep is a command for matching strings in a section of text. So, for example, if I take all of these lines and I do right-click, Topaz Editor commands, run command, if I type the word grep barium, what that should do is it should pull out only the lines that contain barium in the file and remove all of the other lines. But I've clearly got a little bit of a problem with how I'm doing this. I'm doing something incorrect. No, I just had to wait. So here we go. Here's just the barium lines in the file. Or you might want to say, keep everything apart from barium. And so the command for doing that is grep -v barium return. So again, if you're familiar with these commands, you might find them useful in Topaz Editor. If you've not come across them before, it doesn't matter. So there we go. That's got rid of the barium. So I'm just left with the galliums and the oxygens in the file. Okay, so I find that quite useful. The other thing that I end up having to do quite a lot, I often find that in my input files, I've got a whole series of atoms that I've generated somehow, but they all have some conflicting names. So lots of the atoms have got the same name. So what I often want to do is I want to rename my atoms so they've each got unique names. And there's a little trick for doing that. In Topaz Editor, if you click, you hold down Shift and Alt and click again, you highlight a column of text. And then you can do a right click, Topaz Editor commands, create numbers in column. Okay, and if you just hit return on that command, what it does is it creates a series of numbers. It uses 4 digits by default, and it just numbers them from 1 to 6. If you decide you wanted a different numbering scheme, you can tell it to use a different numbering scheme. For example, if you wanted to number them from 100 upwards in steps of 2 and to use 6 characters for the number, you can do that kind of thing. So that can be a very helpful way of renaming atoms. The place I use it most often actually is where I'm analyzing lots of data sets that are perhaps recorded as a function of time, and I want to tell Topaz the time of the different experiments. What you can do, for example, if you've got a series of experiments that started at time 0 and there was an experiment recorded every 60 seconds, you can highlight the column of numbers, you do a right click, insert numbers, create numbers in a column, and I want to go from 0 seconds in steps of 60 seconds, and I want to use the smallest number of characters in the number as possible, so I'll put a 0, and then that will not do quite what I said, but let me just repeat that command. Topaz Editor, create numbers in column, so I want to go from 1, 0 in steps of 60 and use 0 characters. Okay, so that's a command that I need to just remind myself how that works. That's a little bit annoying in the middle of a video, isn't it? Create column numbers, create numbers in column 1, 60, 1 is what I should have put, isn't it? There we go. Sorry, 1, 61. I've got that wrong yet again. So what I need to do is create columns, numbers in a column. I want to go from 0 to 60 and just use the smallest number of characters possible, which is I can enter 1 for, and then it gets numbered 0, 60, 120, 180, 240, etc. Okay, so that's some of the editing tips, tricks that you might want to apply. The next little section is, again, some more tricks for handling lots of data sets. What you may have done already is seen some of the other YouTube videos on handling lots of data. So, for example, there's a tutorial online for looking at an example involving the synthesis of zirconium molybdate, and we'll look at this in a second. So it's an experiment where we were taking a particular material, a precursor phase, and we were heating it in the diffractometer, and as we heated it, it transformed to what's called the LT polymorph, and then a cubic polymorph, and the trigonal polymorph. And the game we wanted to play was to analyze each of these data sets one by one, save the results of each refinement, and try and work out what's the best temperature for making cubic zirconium molybdate. So the way that you handle that kind of problem in TOPAS nowadays is to use a hash list command, where you tell TOPAS a list of files that you want to analyze. And again, the hash list syntax is a little bit hard to remember, so it's not something that I will ever remember it in practice. But in the TOPAS Durham menus, miscellaneous useful commands, there's a command which is insert hash list command. So if you click that, they will get written into your input file in a simple format that you can just edit for the example you're working on. So there's a little bit of help at the top here about how to do it. You give it a list of file names here, a list of temperatures, and a list of times. And then the instructions that you actually need at the top of your input file are these instructions here. So again, hopefully that makes setting up these more complicated refinements a little bit easier. The other thing that you always want to do with one of these variable temperature or variable time experiments is you nearly always want to be saving the results of the refinement to some kind of an output file that you can then plot in another piece of software like Excel or using a Python plotting routine. So one of the things that used to take me a huge amount of time was deciding which parameters I wanted to output to the file and setting up the syntax for doing that. But again, there's a little shortcut for doing that now, which is this shortcut here, insert output lines automatically. And so what happens is if you click that command, it writes a little section into your input file with all of the output parameters set up for you automatically. So essentially what it inserts is a little section here which basically says, if this is the first refinement that you're doing in this particular series, what I want you to do is delete any old results files that are lying around. I then want you to make a new file called results.txt, and the first thing I want you to do is write the column headings at the top of that file so that when I come to plot it later, everything makes sense. And then there's a little section here that says for each refinement I want you to output these specific parameters. Okay, and so the way that little tool works is very simple. What it does is it relies on you having a correlation matrix in your input file, and that's a matrix that will have been written if you have do_errors specified in the file. So what the correlation matrix has, it has all of the parameters that you're refining listed down the left-hand side here. And what I do is I look at that correlation matrix, and if a parameter has got a sensible looking name like scal AL203 or AL203, then I think, well, that's a parameter that the user has actually set up and is interested in, so they probably want to write that to their results file. If there's a long sort of obviously computer generated name, then I think to myself, well, that's a parameter name that's been set up by Alan from the @ symbol. If the user hasn't bothered to give the parameter a name, they're probably not very interested in it, so they don't want to write it to their results file. So that's how the decisions are made about what to output. What you'll often find in practice is as you progress with a refinement, you probably want to write out extra parameters over the ones that I give you by default. So let's say, for example, as well as the weighted profile R factor, you want to write out the RP value as well. So let's create a new line for that, and there's a shortcut in TOPAS editor which is Shift-Alt down key will create a new identical line. And let's output RP as well as RWP. Let's say for the sake of argument, we also want to write out the B cell parameter for aluminium oxide. Shift-Alt down and create a new line for B. So now we're writing out those new parameters as well as the old parameters when we do the refinement. Now the place that I was used to get into trouble, of course, is when I add extra parameters down here, I also need to update the column headings for the output file. And so I often used to forget to do that. And if you forget to do that, your columns and your labels are out of kilter with each other, and so you can get into all kinds of problems. So there is a little command now which basically says, this command here, create the column headings from whatever the user is actually writing out. So if you click on that one, it gives you a new set of column headings to write to the output file, so we can delete the old ones and just write the new ones. If you remember to do that, hopefully you'll stay in sync when you're outputting data. Good. Okay, so the next little section that we'll look at, let me shut the menus down on the left. The next set of menus to look at are the Topaz V8 menus. And so what's in the Topaz version 8 menus is basically all of the common Topaz commands that you're likely to use. So that's set up just the way that it was in JEdit. So for example, if you want to know a command about the top level of an input file, you can pull this menu down, and these are the commands that might sit at the top level. So if you click on RWP, it writes in the relevant command. If you click on goodness of fit details, it will write in all of the potential goodness of fit details. So you can scan through that and find all the commands that might be useful for you. Okay, VS Code plus Topaz commands is the next menu down. This is where there are various shortcuts set up for toggling the behavior of Topaz Editor. So for example, if you click on this Topaz theme, you'll have seen this when you install Topaz Editor. There are various different themes set up for Topaz Editor. I like this light theme. Most of my students tend to like the dark theme. So if you set the dark theme up, it just recolors your input files according to those rules. There's also a technical reference theme, and what that does is it color codes the file in the same way as Alan's technical reference manuals. So let me go back to the one I like, which is Topaz Lite. The other thing that's in this block here is removing ESDs and limits. So you'll know if you use Topaz that if you have two errors set up in your file, then after every refined number, the standard uncertainty gets written, and by default, refined parameters get written in red. If you want to remove the errors and these tick marks, you can just click on remove ESDs from the file, and those get taken away. If you want to keep the errors but just remove these tick marks, for example, if you're passing something to another piece of software, you can click this remove backticks from file, and that just gets rid of those backticks for you. Okay, VS Code and Topaz setup. So we did a default setup of Topaz Editor as part of the installation, but there are some other things that you might like to play with. When you first set up Topaz, you set your Topaz directory. If you have multiple versions of Topaz on your computer, you might want to switch between them. So if I click on this Set Topaz Directory, I can navigate and I can find a different version of Topaz. So for example, this is the commercial version of Topaz, Topaz version 7. So if I select that as my Topaz directory, I get a little pop-up appear, as I mentioned earlier. So you've seen Topaz Editor's got access to all of a whole series of different example files that come with Topaz Academic. If you've got the commercial version of Topaz, you may not have those on your computer. If you click yes here, those will be downloaded onto your computer and you'll have them available for the rest of time. So I won't do that now. What I'll do is I'll go back and I'll reset to my normal Topaz directory for the rest of the video. So that's Topaz version 8. So every time you do this select directory, it does check whether all of your Topaz input writer skills, so these are to do with the artificial intelligence part of Topaz Editor, it checks whether you've got the most recent version, and if you haven't, it asks you if you want to update. Okay, what else is useful? Updating menus you probably need to do. Install macro libraries might be useful. If you click on install macro libraries, there are a whole series of macros that lots of people use that aren't distributed with Topaz. For example, there's a series of macros to do with writing CIF files that Matthew Rolls has produced. There's a series of macros that I've written, which I call johnlocal.inc. There's also a series of macros from Paolo Scardi and colleagues, which let you do WPPM modeling. So if you want those installed on your computer so you can use them all the time with Topaz, you can just select them, click OK, and they'll get installed in your Topaz directory so you can use them in the future. There is a little warning that comes up. I've already got a version of sif.inc, so I probably don't want to overwrite it in case they're different. I don't want to overwrite my version of local.inc, and I've already got the wppm.inc there, so won't actually overwrite. Sorry, I've just realized I have overwritten everything, so hopefully I haven't caused any problems. Good. What else is worth mentioning? Just mention hover help. Remember I said that when you put your cursor over a Topaz keyword, you get a little help menu popping up on the screen which tells you what that command is all about. If you find that annoying, you can turn it off. So you can just over here, you can toggle off the hover help, and a little menu comes up saying, a little window comes up saying it's disabled. Now when I hover on a keyword, I don't get those pop-ups. I like them, so I'll put them back on. The other decoration that I put in your input files by default is every time there's an XDD structure in the input file, I put a solid green line above it. And every time there's a structural section, I put a little dash green line above it. And it just means that if you've got a big complicated input file, you can see the different sections very, very cleanly. If you don't like that, then you can toggle off those decorations and they'll disappear. I like them, so I'll put them on again. Okay, the other thing I will just mention, so there's a whole load of commands that you access via these menus here. You can actually access them all directly using the command palette in VS Code. So if you type Shift-Control-P, you get all of the commands that are available in VS Code, and there's a bewildering number of them, of course. If you type Topaz, you'll get just the commands that we've set up in Topaz Editor. So there's a whole series of commands here that you could just access like that if you don't like using the menus on the left. Good, and then there's only two sets of menus left. There's the TOPyAS Artificial Intelligence Interface menus. We're going to cover those in the next video. So the final set of menus I skipped past are these TOPyAS menus. So as I said in the introductory video to Topaz Editor, one of the nice things about VS Code is it plays very nicely with Python. And that means that we can wrap some Python scripts around our everyday analysis, which lets us speed up some of the things that we're doing. And just to give you an example of that, I'm going to look at one of these variable temperature refinements that I mentioned a few minutes ago. And again, this is an example that's in one of the online tutorials, and it's the example that we've just mentioned. This is an input file for analyzing the zirconium molybdate data. And you can see it's one of these variable temperature experiments. So it's got these list commands that we talked a few seconds ago about how to set up list commands so that you can do multiple refinements. And then at the end of the refinement, it's got these commands that output the results to something called results file. So just to give you an idea of some of the things you can do, I'm going to send this file to Topaz, and I'm going to switch to Topaz Academic. I'm going to delete everything that's in there, and I'm just going to run through these Rietveld refinements. So if I click play, I should read in the first Rietveld refinement, and that should converge. And then Topaz will slowly analyze, or actually slowly, relatively quickly analyze these sequence of diffraction patterns as we're taking a material, we're heating it up in a diffractometer, and we're recording data as a function of temperature. And so just because we're waiting for this anyway, you'll know that if you've seen the other videos, that Topaz has got some really nice features for looking at variable temperature diffraction data in 3 dimensions, or multiple data sets in 3 dimensions. So for example, you can show a 3-dimensional surface of the diffraction data. Let me just take off the tick mark so things are clear. So for example, here you've got a nice 3-dimensional plot of the Rietveld refinement data, and if I hold down the control key, I can see each of the individual Rietveld refinements just by dragging across the surface. I tend to like looking at things in a little two-tone view. This is a two-tone view of the same diffraction data. And in the two-tone view, what's rather nice now is if you put the tick marks on in Topaz version 8, you can see very nicely how different phases are, how their peaks are moving as a function of temperature as different phases come and go. So that's running through everything now, and it's got to, it's done 50 of the 68 Rietveld refinements. So that's almost done. So let me minimize that window and show you that as that refinement is happening, what's getting written in my directory is a file called results.txt, and so that should have the output of the result refinements. Let me just check everything's finished so that I don't mess up. No, I'm being impatient. There are 3 more refinements to run, so I need to get to number 68 before that file's been written. Okay, so that's finished now. So the results are written in this file called results.txt, and if I open that with VS Code, you can see it's just a very simple text file which contains all of the parameters that I've output. Now, by default, this looks a little bit messy as a file because the columns and numbers aren't lining up nicely with the titles. There's a nice little trick in TOpyAS editor. If you highlight everything, you do a right click and you do align columns. There's an option here behind my head which says align columns by separator. If I click on that, I type a space and I click return, then the file gets beautifully lined up in columns, and so then it's now very easy to sort of see what these different parameters are. Now, of course, you can take this file and you could plot it with any piece of software that you like. For example, you could import into Excel and plot the data. I tend to be a little bit impatient and I want to see my results instantly. So what I often do is I use a little built-in script in TOpyAS editor, which is called plot refinement results. So if I click on plot refinement results, what it does is it copies a file across to my computer, which is called plotall.python. It's a little Python script that basically just says, this is the name of the file. I want you to plot on the X column the run number, and I want you to try and plot any columns that you can find in that file. The little Python script is running in the background here. And again, it's slow because I've got lots of things open on my computer. But what that's meant to have done is, yeah, it's finished already. It's made a whole series of plots for me with, for example, a plot of the R factor as a function of run number, or the goodness of fit as a function of run number, or I've got the weight percentage of phase 2 as a function of run number. So you can look through those plots very, very quickly. So that's an easy way of working. If you want to, you can just change the plots a little bit. I'm plotting there. I'm plotting the run number as my X column. There's actually a column of temperatures in that file. If I want my results as a function of temperature, I just change one word in my input file and let me run that script again. I'll run it from the command line, python plot_all.py. Normally I would run it by just I have a little button here in TOpyAS editor that does that automatically, but I've just realized because I did a fresh install of TOpyAS editor for this video, I haven't set that up yet, so I need to go back and do that. So now I've made a whole series of plots where instead of plotting as a function of run number, I've got the same plots, so as a function of temperature instead. So it's very quick to produce multiple plots. So I find that very useful. The other thing that I find useful is, as well as using this this quick plotter, I often use something called TOpyAS Live Plot. So what TOpyAS Live Plot does is, again, if you click on that, it copies a little script into your directory called liveplot.py. And that's a script where you just need to tell it what columns you want to plot, and you can get beautiful sort of multiple plots on a single sheet. And I've set one up for this refinement already called liveplot_zrmo208.py. So let me just open that. And what I'm doing in that particular script is I'm saying, well, what I want you to plot, I want you to plot run number on the x-axis. Then I want you to plot a graph of the temperature, the R factor, any scale factors you can find, and any weight percentages. So if I run that, if I do Python live_plot_zrmo208.py, if I run that script, we can see what kind of plot that produces. And again, it appears on my other computer screen by default, which is a little annoying, but here it is. Let me just make this a slightly more sensible size. So this is now a plot of the key refinement results that we can look at. Now, The nice thing about live plot is it actually sits there and it waits for results coming out of a TOPAS refinement. So if we were to go back to TOPAS and we were to delete all of the refinements and we were to repeat the Rietveld refinements again, if you remember, I said the first thing that happens when you do one of these multiple refinements is TOPAS deletes the old results file. So there's a clean file for it to work with. And so if I start the refinement again, the old results file should get deleted. And if I go back to the live view feature, can you see that what's happening now is these Rietveld refinements are happening in the background. So I'm currently on refinement number 10 or something, number 6. And what live plot is doing is it's plotting the results of the Rietveld refinement as they happen. So again, it's a little bit slow on this computer because I've got lots of things open, but you can see that I've got a plot here of the temperature of the experiment as a function of the run number. So run number 10 was a temperature of 500 Kelvin. In the plot on the right here, I've got the R factor. So this is the RWP as a function of refinement. So these RWPs are all nice and flat at about 8.5%. But the interesting one for me here is this plot here of the weight percentages. You can see that up to run number 10, which was a temperature of about 400 Kelvin, I had what's called the precursor phase, which is phase 1 in this particular refinement model. And then at about 400 Kelvin, that completely transformed to a new material, which is phase number 2. And that's a polymorph called LT zirconium molybdate. So one phase has transformed completely to another phase. And then for the next little temperature regime, up to about 700 Kelvin or so, that's the material that's present. And then that material actually decomposes and it transforms to this green phase, which is actually the cubic zirconium molybdate that we're trying to make in this particular experiment. And so by the time we get to a temperature, what's this? This is range number 44, a temperature of 800 Kelvin, we've got essentially a phase pure sample of zirconium molybdate. So if we want to go back to the lab and actually make this material, we now know instantly that 800 Kelvin is a perfect temperature for making that material. If you heat too much higher, if you go up to about 850 Kelvin, can you see that on this graph in the bottom right, the amount of cubic zirconium molybdate is starting to disappear. And the reason it's starting to disappear is this red phase here, which is actually trigonal zirconium molybdate. It's another polymorph that we're trying to avoid. The trigonal polymorph starts to form. So again, very rapidly from one of these in situ experiments, you can work out the best temperature to make your material. In terms of pure sort of powder diffraction analysis, if I'm doing a complicated analysis and I'm likely to be doing it multiple times, I'll typically set up one of these live plot windows and then I can just watch instantly what's happening in the refinement and I can see when there are problems. So let me shut that window down, and just so other things don't go too slowly, I'll close TOPAS and close this terminal and come back to the main part of the talk. There are a few other things here in this TOPyAS menu. I won't go through them in detail. Just one more example, PDSIF plotter. I think in some of the other videos I've told you about a beautiful piece of software that Matthew Rawls has written, which lets you analyze SIF files and plot the results in SIF files. So again, because I tend not to remember the command for running that piece of software, I just have it as a shortcut menu that throws up PDF plotter, and then I could load a file in if I wanted to. So again, lots of things you could do to customize the way that you work with TOPAS. And I think the final thing that I was just going to mention in terms of customization, there is a little script at the bottom here which is called My Menus. If you click on My Menus, it gives you an option. There's an option for how to insert your own menus to work with TOPAS. So you store those menus on your computer, and then every time you need them, you can just install them and they will appear on the left-hand side here. Good, so I know there are quite a lot of different things in that tutorial. Hopefully it's given you a feeling for some of the things that you can do in TOPAS Editor, some of the power tricks you can use. Certainly some of these things make my work a lot easier on a day-to-day basis. I can do complex analysis a lot more quickly than I used to do. I mentioned already, but it's actually relatively easy to set these kind of things up in TOPAS Editor. So if there are things that you think would be useful to include, just drop me an email and I can think about building those in so that the whole community can share them. So that's everything about Topaz Editor itself. In terms of power editing, the other trick that we've got in Topaz Editor, which I haven't talked about in this video, is the TOPILOT artificial intelligence interface. And that's going to be the topic of the next video. So we'll look at how you can do some even more powerful things more quickly in a more automated way using artificial intelligence. So I look forward to seeing you in that next video. Bye for now.